students, once again welcome back for the continuation of chapter 5 in chemistry, that is periodic table. Today we shall discuss about Mandolin's periodic table. Before I start this, I would like to recapitulate that we have done in previous class. As you know that many attempts were made by different scientists to classify the elements in order to make their study easier and systematic. First, all chemists they classify the elements as metals and non-metals. After all chemists, J.W. Daubigny, he classified the elements in group of 3, which is known as Daubigny's traps. Here, Daubigny's law of traps state that when the elements are arranged in group of 3, the atomic mass of middle element is almost equal to the average atomic masses of other 2 elements. Here, Daubigny's law of traps was also discarded later on because he failed to arrange all the known 63 elements in the form of traps. It means that this idea of classification did not work for all the elements. And this idea of classification did not work even in the same group as in the case of halogen. Then after Daubigny, John Newland, who was a lover of music, his law stated that Newland's law of octaves state that when the elements are arranged in the increasing order of their atomic masses, the properties of the 8th element are similar with the properties of starting element, as in the case in musical note. Here, 8th note has similar properties as similar with the starting note. As you know that sa, re, ga, ma, pa, dha, ni. Right? Sa. So 8th note is similar with the first note of music. And this Newland's law of octave also discarded later on. After the discovery of noble gases, this idea of Newland's law of octave did not work. Here neon comes between fluorine and sodium, and argon comes between chlorine and potassium. Here becomes 9th element, not the 8th element, show similar properties. And here this Newland's law of octave did not work well for heavier elements. It did not work beyond calcium. As more and more elements were discovered, and this element did not fit in the Newland's law of octave. Now, let's move on to today's topic, Mendel's periodic table. Dmitri Mendel in 1869 studied about the properties of 63 elements. And he arranged the elements, in the increasing order of their atomic masses in the tabular form, which is known as Mendel's periodic table. And he proposed his law, which is known as Mendel's periodic law. And this law, Mendel's periodic law, states that when the physical and chemical properties of elements are periodic function of their atomic masses, this classification was based on atomic mass. According to his law, when the elements are arranged in the increasing order of their atomic masses, elements with similar properties repeated after regular intervals. Now next year, the main features of Mendel's periodic table. Number 1, he arranged the elements in the increasing order of their atomic masses in a tabular form. Number 2, he divided this table into 8 vertical columns which are known as group. The elements of the same group show similar properties and same valency, which is equal to their group number. Number 3, third point. Again, he divided this table into 7 horizontal rows. Horizontal rows means left to right, which are known as period. So here, the elements of the same period show gradual change in properties, like from metallic to non-metallic. As you move from here left to right in the periodic table, elements which are changes from metallic to non-metallic, or from electropositive to electronegative. Now next here, merits of Mendel's periodic table. Grouping of elements. He generalized the story of the elements and then were only in the 8 groups. Number 2, gaps for undiscovered element. He left spaces or gaps in his table for undiscovered element, and he knew that these elements will discover later on. Now third one here, prediction of the properties of undiscovered element. He predicted the properties of elements which were not discovered at this time. Like Eka element, aluminium, which means one place just below the aluminium. Here, the atomic mass and chemical properties similar to that gallium, which was discovered in 1876. Similarly, Eka silicon, which is similar to germanium. Now next year, number 4, incorrect the atomic mass corrected. He corrected the atomic masses of some elements like gold and platinum. Now next comes your demerits of Mendel's periodic table. First one here, position of hydrogen was not defined or confined, because here the properties, some of the properties of hydrogen are similar with the alkali metals as well as halogen. That is why the position of hydrogen was not defined. Number 2, lighter element was placed after heavier element, which was contrary to his own law. Here once again, lighter elements were placed after the heavier elements, which was contrary to his own law. His law stated that the physical and chemical properties of the elements are periodic function of their atomic weights. Now he placed potassium after argon, which was the contrary to his own law. Now next here, position of isotopes. You know, isotopes are the atoms of the same element having same atomic numbers but different mass numbers. Why do isotopes have different mass numbers? Because they have different number of neutrons. According to his law, isotope must get space in his table, but he did not assign the places for isotopes in his table. Now last one, here number 4. Chemically similar elements were placed in different groups and vice versa. Like copper and silver. The properties of copper and silver do not match with the properties of alkali metals. So here, the elements which are their properties do not match, they are placed in the same group. And the elements which have similar properties like gold, platinum, they are placed in different groups. Now here, his table did not reflect the electronic configuration of the atoms. Here we have come to the end of today's online class. Thank you very much.